Center for Automotive Research. I'm going to present my thesis. And my title for the thesis is Effect of Split Injection Timing and the Fuel Fraction Distribution on the exhaust temperature, smoke density, and the engine noise from the single-cylinder Hartz engine. And my advisor is Professor Marcel Jensen. And under his guidance, I have learned a lot of things, and Professor Khaira and Dr. Lee also. So initially, I'm going to go through the presentation outline. So we will discuss first of all the objective of the project, what's the basics, what we have, like why we do this project, and who's the funding of our project. And after that, we're going to look at the introduction and the literature review also. So there will be some part of that because like I can't include all of them in the whole literature work. So then we will see the engine specification, then the engine setup after that, and then what are the test conditions we run the single-cylinder Hartz engine. And then the main thing is to see the effect of engine noise. There was one technique called the in-cylinder pressure decomposition technique. So we're going to go through in a little bit detail in that stuff. And then the results. And after that, the conclusions, recommendations, and then the acknowledgement. So now you will see the objective of the project. So this project is funded by the TARDEC, and the basic objective of the project is just to we have to construct the unmanned ground vehicles, and the basic purpose for that is for the acoustic is to, like you can see that the acoustic is in which we can produce the threshold for the threshold hearing of the pain. So there are basically two concepts. One is we see like threshold of the pain in which we can't bear the noise from the product, and the main purpose one is that to produce such amount of noise from the engine so that nobody can, we can get irritated with that noise. And another basic purpose is the smoke generator, so we can disperse the crowd. And another is to make the exhaust temperature so much high so that we can deviate the missiles from our tanks and from the persons also, so that we don't get any injury and so that we can't destroy our property also for the United States. And now we'll talk about the introduction. So diesel engines are the attractive source in the automobile sector due to their higher thermal efficiency, and so they have some drawbacks also, like for the pollutant emissions and the engine noise. So these are the main drawbacks like diesel engine are facing from a long time. And but with the injection strategies, like with the common rail, the split injection timings, and by changing the start of injection pressure, we can nowadays we are meeting the emissions like Tier 4 final and those kind of stuff. So they played a really vital role in the reduction of the emissions, noise, smoke, and temperature also. So now we will talk about the engine noise. So the engine noise is basically is a combination of two things. One is the mechanical source, and another is the combustion source. So the mechanical source is just we are motoring the engine, that the noise coming from the piston slabs, gearing reel, valves, just from the combustion valves by the just pumping it without injecting the fuel. And then is the combustion noise. So combustion noise is basically when we inject the fuel and we have an ignition delay and we burn the fuel. Then after that we have certain rate of pressurize, and the gases which we move and they hit the combustion valve, and we get the combustion noise from the engine. That's the burning of the fuel basically is that. And so the combustion noise is mainly dependent on a lot of things: the combustion geometry, bowl geometry, compression ratio, and the ignition delay also. So if you have a higher ignition delay, we're going to have a lot of engine noise, and if you are like asymmetry crown coil, then we can have a lot of resonance from the engine also. The peaks of the resonance can go high also. So these are the main factors which affect the engine noise. Now we're going to go through some of the literature review, like some research. They did their own research in the emissions, in the noise also, smoke also, exhaust temperature also. So in this essay paper, according to Longzhang, so according to him, he said like noise is directly proportional to the rate of pressure rise. Like it is basically rate of pressure rise we got from the combustion mixture of the ignition delay. And according to him, like we have learned, like longer the ignition delay we have, the higher the rate of pressure we will have, and higher is the engine noise. And he discussed about the effect of the pilot injection. So first two columns, like first two lines, they show the with pilot injection, and the bottom is the without pilot injection, that's the single injection only. So according to him, if we do the pilot injection at any before the main injection, we will have the lower ignition delay for the main injection, because we're going to inject the fuel and we're going to raise there's a small amount of fuel, we're going to increase the cylinder temperature, temperature, and then we will have a lower ignition delay for the main injection, and due to which the fuel doesn't get that much time to mix with the air, because that will have the main portion of the fuel, and we will get the lower premix combustion and rate of pressurized, which will lead to lower engine noise also. And according to him, like he said, like with the pilot injection, ignition delay of main injection increases, which contributes to the reduction of the combustion noise by lowering the premix combustion fraction. So the combustion noise also main from the like pilot injection also, if you inject the more amount of fuel in the pilot rather than the